Our objective was to design a H-bridge circuit having flyback diodes and optocouplers to control the direction of the motor. H-bridge is an electronic circuit that switches the polarity of a voltage applied to the load using four switches. The switch can be manual switch or BJT or FETs acting as a switch. When the switch 1 and the switch 4 are closed, the motor will move in the clockwise direction, and when the switch 3 and 4 are closed, the motor will move in counterclockwise direction. In this way, we can move the motor in forward and backward direction. These are the components that we use in our circuit: transistor for switching purpose, diode as a flyback diode, optocouplers for the unidirectional flow of current, motor as a load, battery, resistor, and LEDs. The resistors that we use in our circuit are TIP, NP, and BJTs in T20 packages. So TIP122 consists of a Darlington pair, and it internally consists of a flyback diode for the safety of BJT, and its maximum selector current rating is 5 ampere and a gain of about 1000, and it is used in the switching application and power linear applications. The diodes that we use in our circuit are used as a flyback diode, and the flyback diodes are used to protect the circuit, and these are connected in reverse bias in normal conditions. So when the current comes from the battery, it will act as an open circuit and no current flows through it. But when the reverse current or back EMF is generated by the motor, that current will pass through the diode, because that current could be very large that can damage the BJT. So it will pass through the diode instead of passing through the transistors. Optocouplers in our circuits are used to isolate the input circuit from the output circuit. The optocoupler consists of an infrared emitting diode and a phototransistor. The phototransistor is optically coupled with the diode. So when the diode is on, then the BJT will on. If the diode is off, the BJT will act as a open switch. So when the current from opposite side comes, the BJT will act as an open switch and no current flows through the optocoupler. For calculating the value of RB, first of all we take the values of IC, beta DC and the VCE from the datasheet of TIP122. Then we find the IB by using the formula IB equals to IC by beta DC. Then by putting the value of IB in the equation VBB minus VBE divided by IB, we get the value of RB 8.9 ohm. In practical circuit, we use 1 kilo ohm circuit because it is commercial, because 8.9 ohm resistor is not commercially available in the market, so that's why we use 1 kilo ohm resistor in our circuit. So this is our H-bridge circuit to control the direction of the motor using 4 NP and TIP BJTs. A 9-volt battery is connected to the two buttons through the resistor. A positive voltage is applied at both the buttons. Then the optocoupler is attached with the switch. The optocoupler consists of infrared emitting diode and an NPN transistor that is optically coupled with the diode. When the BJT is closed, the diode will on the BJT, and the current flows through the optocoupler. Now the H-bridge consists of 4 BJTs. The collector terminal of the upper BJT are connected to the positive terminal of the battery, and the emitter terminal of the lower BJTs are connected to the ground or negative terminal of the battery. Now the BJTs will on when the positive voltage is applied at the base of BJT. So that's why the collector of optocoupler is connected to the collector of the battery, and emitter terminal is used for the output. When the upper button is pushed, the motor will move in the forward direction, and when the lower button is pushed, the motor will move in the backward direction. Both the buttons should not be pressed at the same time. Now for the protection of the BJT, the flyback diodes are connected in reverse bias in parallel with the BJTs. When any reverse current or the back EMF is generated from the motor, it will pass through the flyback diodes instead of passing through the BJT, because this current can be very large and can damage the BJT. This is the automated edge bridge circuit using arduino. In the circuit design, we can control the motor by arduino and also by manually by using the switches. When the switch is closed upward, it will tell the arduino to run the motor according to the code, and when the switch is closed downward, the motor will run manually by switching. When the button will press, it will give signal to the arduino to run the motor in forward or backward direction, and the arduino will control whether the motor will move in forward direction or in reverse direction. And this is the code for arduino, and in the void setup, we define all the pins that we use in arduino as input and outputs. After that, in the void loop, first of all, the code will check whether the switch is upward or downward. If the switch is upward, then this code will be run and the motor will move automatically. After that, when the switch is downward, it will allow us to move the motor manually, and then it check whether if the upper button is pressed or the lower button is pressed and move the motor accordingly in forward and reverse direction.